Bismillah ar-Rahman ar-Rahim. Inshallah, today I'm going to speak about the load encouragement in distance protection relay. In this section, I'm going to speak about what's meant by the load encouragement. Then we'll see how the load encouragement could be affect the distance protection relay. Then we'll see some example and some study cases about the load encouragement and how to protect the distance protection relay from maloperation during the load encouragement. First of all, the load encouragement means during the heavy load in my power system, the distance relay could be trip or unnecessary trip. As we know, the distance relay, it's worked by the measuring the impedance along the line by V by I. So now let's do some study cases, some example about the load encouragement so you can understand more about this. So assume now I have line 33 kV line and the maximum load current is this 1000 amp. Now the setting of the distance protection relay, what we have, assume now the zone 1, the reach value 10 ohm, it's cover 80%, time delay instantaneous. Zone 2, the reach value is 50 ohm, it's covered 120% and time delay is 0.4. Zone 3, it is the reach value is 20 ohm, it's covered to 20% and the tripping time is 0.8 seconds. Now let's draw the Mohawk characteristic. This is R, here will be X. Now assume this is the zone 1, this is the zone 2, and this is the zone 3. This is zone 1, this is zone 2, this is zone 3. This, as we know, it is Mohawk characteristic. Sometimes the zone 3, we will make it as offset Mohawk characteristic. As you know, you see in Mohawk characteristic, it is protect from the zero. Sometimes I need to protect the below the zero here. Sometimes the zone 3 will make it is forward, same time it's look also the reverse, like this one. This place here, we'll use it as backup protection for the bus bar. Backup protection for the bus bar. This we'll see more deeply when you're going to speak about the characteristic in distance protection relay. Now, let's assume this the zone 3. Okay. Now let's calculate the impedance during the maximum load current. So, when you calculate the impedance during the maximum load current will be how much? 33 kV divided by 1000. So the answer will be 33 ohm. Okay, so this 33 ohm, we'll consider it's here. It is very far from my zone protection of the distance protection relay, because as we know, zone 1 is protect from 0 to 10, zone 2 from the 10 to 50, and zone 3 from 50 to 20. So 33, it is far. So the distance relay, he will see this value, so there will be no action. So there will be no action from the distance protection relay. Now assume we have heavy load. The current will increase, assume 50%. Now let's assume the current will increase 50%. So the current will increase 50% will be, assume now the case 1 will see, because during the heavy load sometime we'll get some drop in voltage. But in my power system, we always will make two things, it's constant, it's frequency and the voltage. Now let's see the case 1 during the heavy load but with the constant voltage. Now assume now we'll increase the load 50%, so will be 1500. So now let's calculate the impedance will be equal to 20 ohm. Now you check the distance relay, he will look the value here near to the zone 3. Near to the zone 3, but will be no action because still out of my protection area. Now assume it is increased to 100%. So will be here 2000. So the answer will be 16.5 ohm. So now this, it's located in zone 3 here. So the distance relay, and when you come here after the setting time 0.8 second, the distance relay will trip or unnecessary trip. But the distance relay here will trip. Why? Because the distance relay is look now this value, and as you know, the heavy load will not consider as real fault. So the distance relay should be blocked and will not trip. So by this case, the distance relay could be tripped. Now let's see the case 2 during the heavy load with some drop in the voltage. Now assume the maximum load current will increase 50% and we'll get some drop voltage about, let's say, 10%. So let's calculate now the impedance when you get some drop voltage. Now let's see 33 kV multiplied by 10%. Okay. So will be equal 29,700. Okay. Now assume here the current will increase, let's say 1,800 amps. So let's calculate the impedance. So also will equal 16.5 ohm, and again the distance relay will see in zone 3. So what we know, the load encouragement mostly will affect the zone 3. Mostly will affect the zone 3 because during the heavy load, the current, the impedance will try to reduce slowly, not like the inrush current in power transformer. So mostly will affect the zone 3. So now how to protect the distance protection relay from the load encouragement? So it's protected by use some element we call load blinder element. So what's how the load blinder will make? So we'll set some angle like this from both sides. Okay, now after set some angle here, even the reach value C in zone 3, the distance relay will not trip because we'll make some load blinder. So I make the distance relay, he will not see this value. So like I blind the distance of the relay. So the distance relay, he will not see this. So the distance relay, he will not trip. So by use load blinder element, the distance relay could be block the load encouragement. So I hope this section was very helpful to you, and this small explanation about the load encouragement. Then next video we'll see about the power swing. Thank you so much.